We live? Yeah, we're live. Hey, folks. Let's fix the chat. Cool. So, let's make a quick couple of posts. What on earth is wrong with this? Now this is showing my stream, but the title's wrong. Okay. Weird. What on earth is wrong with this? Now this is showing my... stream, but the title's wrong. Okay. Weird. What on earth is wrong with this? There we are. Hello, folks. Let me figure out how do I download my own VOD. It should be on YouTube, right? Videos, live. Yeah, perfect. There's a download button here. Download. Channel. Manage videos. Live. RL. Wait, upcoming. Huh? Why does it not show? Summit went well, 20. I'm trying to get the VOD so we can get it edited. Does anybody know what the heck is wrong with this? YouTube doesn't... I think it does let you download your own VODs, right? I just don't see the button. Does it actually not let you download your own freaking VODs? Wait, hang on. We gotta get this to him. So Weston's gonna edit this together because I goobered it. And I didn't show the slides. Why does it not show up because I'm still live? Let's see. Your channel. Live. I see it here. Oh, download. Download unavailable. What the hell? Why is download unavailable? YouTube download on. The heck? Oh, is download, is this a premium thing where it's not actually letting you download it? It's just like... Well, Twitch will let me do it, right? Here, let's try Twitch real quick. You got a downloader? I think I can get you higher quality, though, if I give you the VOD, can't I? If I just, like, G-drive the VOD. Oh my gosh, where is this? Content, video, producer. What the heck? Stream summary. Not a VOD storage enabled. The Restream have it? I might be able to snap it off a Restream. Let me go grab it off Restream, actually. Restream saved my last few VODs. Download recording. Landscape video. Audio. Cool. So I will just slap that into a Google Drive once that downloads, and as agreed. Oh, and give you the slides as well. So I will give you, hang on, new folder, folder, 1000x, faster. That goes there. And then this goes here. I upload that to Google Drive. And in a second, I'll update the other one. And how does he know what slide you were on during the video? It's pretty obvious, like, talking about it. Like, he knows the stuff I'm talking about as well. As long as it's pretty close, we're good. This is actually way better than hiring a non-technical editor. Weston, do I have an email for you? You can DM me one on Discord so I can share the Google Drive. Oh, actually, wait, I can just give it with anyone with a link here. Anyone link view, it's fine, I got you. I can just send it to you directly. Wait, which account though? DM me from your, whichever account you're using now though, so I know who. Here, there it goes. See if you can access this. The video is still uploading. It'll be there in a minute or two. Let's see if you can access this. Nah, just edit like just the presentation together with the slides. You can do it like I have my camera here or however is reasonable. Yeah. It's basic. Make sure it still gets like, make sure it gets exported max res. And $100 for editing as agreed. PayPal or Venmo or whatever is easiest. Cool. All right, now that was not too bad of an error, since that'll be sorted out. Tiv made. And we should be good from here. So for the folks here for development, welcome. We go back to dev. Works can see it, good. Yeah, whenever you got time to get to it. I'll be putting it on YouTube and X. Breakfast. Yeah, see you around, man. Alright, so what we're going to work on at the moment, and this is actually a good spot to have some user feedback. So there's a lot of complexity associated with making the networks at the moment. And some of it's unavoidable because like the thing that we're doing here is much more sophisticated than what Torch is doing. I'll show you what it looks like. Yeah, so right now, I can clean up the signatures for this, but there's a rollout buffer, there's a train buffer. The rollout buffer has to store any activations that your network needs while you are doing forward passes. So any like intermediate data storage has to be there. And then in training, there are also things that need to be stored so that you can compute gradients. There are additional buffers that need to be there. So that's what the train buffer is. And then the encoder itself, it needs to have pointers to all the different functions that are required, which are forward and backward. That one's obvious. But then like weight initialization and then the registration of all those buffers here. So the functions themselves are pretty simple, right? Like the forward function is just a matmul, the backward function is a different matmul with the grad, the weight initialization is an orthogonal, there's a registration of parameters where you just have to tell the shape. The encoder registration here, this is the shape for the intermediate buffers. Rollout buffer is one registration. If you look at the actual code here, there's nothing super complicated. And like, I'm going to fix up the names and stuff so that this is not super long and gross looking. But it's kind of annoying that you have to define 1, 2, 3, 4, 5, 6 different functions in order to just like make an encoder. And I can't really see any way around it. Like, it's not like Torch, where Torch just allocates memory all over the place willy-nilly, right? This is static memory. So the trade-off of that is you actually have to allocate the static memory. Does this make sense? Or am I, or is this just going to confuse the crap out of everybody? Also, I can go put this back on my other monitor. I think it makes sense. I think it's like messy, but I think it makes sense. If there's a better way to do it, though, by all means, folks, you can shout me and I will look at it. And let's ban this bot. So other sources of complexity in here. Muon update's kind of a mess. Muon and init, Muon register buffers. That's kind of weird. I think these two can get combined, can't they? Okay, that's one very small thing. Oops. Policy forwards, policy backwards. I think there's some jank right now with low precision. There's some jank with the low precision that we got to look at. Usually BF16. Computed and accumulated in FP32. Wait, so this is... Are static methods useful here? I don't know. What do you think it would... What do you see it looking like? So... the thing with the decoders and encoders, right, is there's just a ton of buffers that need to be registered. And you register everything with the allocator, and then at the end, right, when everything is registered, then you also need to, like, populate the weights separately. So you can see, like, the decoder, for instance, it has the same thing. There's a forward, there's a backward, there's a weight in it, there's 3 registration functions. They're individually very simple, except this one, because there's a continuous gradient thing here. But yeah. Look at this in the meantime. What are you doing, CUDA, or is this CPU work? Wait, are you... I mean, the whole nets are in CUDA. You see their launch functions are just inlined. Accumulated in FP32. Okay. I'm basically just trying to figure out what's a sane thing to approach, a sane way to approach the mixed precision here. Small bat metals. Gradient noise is high. Very low. Per parameter is large, yes. No, we have very large steps. This is a little tough because, like, I think this needs to be empirically ablated, right? Like, I can't just go make these changes and then say, ah, well, okay, they work on breakout. We need to test this on minimum 2048. There's a bunch you can do. YouTube chat is slow. Fused MOE gems. Wait, we don't have mixture of experts, dude. This is small model reinforcement learning. So this is raw CUDA, ultra high performance, like 10 million plus steps per second training, models between 20,000 and 10 million parameters. Typically, our models are like a few 100,000, like 200,000 to 2 million is most common, I would say. Yeah, that's the main regime. Oh, for the D-type handling, like the approach? Yeah, so I'm trying to figure out if, yeah, so for that, I'm trying to figure out if there are meaningful differences because of our problem setting and how we should be handling mixed precision, right? Because we have pretty small models with big batches and large updates. So there are a lot of places where you could keep stuff FP32 or put it BF16. I don't think there actually is a super good guideline here, other than us like running training on our hardest problems and making sure it works. What GPU architectures? Mostly the consumer cards. Most of our experiments run on like 4090s and 5090s. Just because they're really cost effective. We're not at all bound by VRAM, so the VRAM is essentially useless to us. I actually, to be fair, I have not tried our new optimized code on the high-end cards. It could be that with our new optimizations, everything's super fast there. I frankly have no idea. That'd be kind of cool, honestly. 100 million step per second training. Probably use PTX ISA LD matrix. What? PTX ISA. We're not writing raw PTX. What is this? Wait, isn't PTX just their like their aggregate instructions, like if you want to call raw, like raw tensor core ops. Like the thing, man, is we don't have. So the thing we're doing. It's a little bit different. So like we're not writing attention ops, for instance, right? Like the core of what we're optimizing isn't the map mul. Cute. Yeah, we are using cuBLAS. But like the thing is, we are not. So our ops don't like involve fancy map muls. Like attention, it's a bunch of fancy map muls, right? Like most of our kernels deal with gates and activations. Um, like the actual core compute load is not attention ops. It's just linear layers. So those are like really easy. Just throw cuBLAS at it, done. And then the thing that becomes difficult is having like, we need to massively fuse kernels, which we have. And then we also have this mixed precision workflow and a bunch of other stuff around that. Not using Qt. Raw cuBLAS has been good. Element-wise, mostly there's a lot of element-wise muls. Yeah, a lot of element-wise ops in general. There are a few sequence ops that are not map muls as well. Because the architecture, there are a bunch of gates, and then there's a fuse scan, like a prefix scan operation. That's the big, fancy non-map mul kernel. That's kind of the core of all of it, because it's a min-gru-based architecture. So it's like a simple state space model, but it has to be super fast. And that's the main thing. I don't think there's too much I can do on the optimizer right now without risking breaking things, because these are actual, like, I should probably have a good version of at least 2048 as an ablation environment before I do that. So, okay, other than Muon, what other stuff can we look at? Other than min-gru? What else is in this file? Advantage CUDA, Prio Preplay CUDA. Forward backwards. Prefix scan kernels. NVIDIA the routing kernels. Where? Where should I be looking in here? Massive. Wait, how is routing similar to prefix scan? C source. Okay, what if this would be similar to I didn't think MOE had. I didn't think this had anything like a prefix scan, does it? Is one of these similar? Hmm. Well, this is kind of cool. They just use raw. Yeah, this is cool. Like top K, isn't it, right? Align sum. This isn't it, right? I don't know which of these you think would be similar to a prefix scan. At the very least, this is way less bloated now. Grouped top K. Wait, I'm confused. How on earth is grouped top K? How is this similar to a prefix scan? Is there like a merge op that's similar or something? Oh, I guess you mean like this stride operation, I guess? Scan ops and then use softmax. Scan ops. Per group scan. I mean, this is like a log end stage reduce, right? Isn't that what it is? Goal is March 31st. No, Jess, yeah, if I can get it by March 31st, I'll be very happy. The goal is like, yeah, that would be when I would like to have it done. It's going to be released when it's released, though. There's no way it's not close at the moment. I'm working as much as I possibly can on it. Um, there is somebody in the Discord. I don't know. It's not you, right? That's like was offering to optimize. I think specifically the fuse scan. Now, the one thing I'm not sure about with the fuse scan is the sequence lengths at which it is more effective to just do a linear op versus to do a multi-stage reduction. Let me actually look at this. Yeah, I don't really like the way that it's a bunch of these little kernels. Maybe we should just clean this up a little bit more first. I think it's still too hard to reason about, right? Grasshopper. Yeah, let me actually. Did he reply to my I asked him like what specifically the course was, the requirements. I don't think he's replied, right? No. Wait, what's the Discord? I'll go through repo and let you know. Discord.gg/puffer. So right now, this is the, what is this? This is static native. Yeah, static native. So basically what happened here is the latest 4.0 has the Torch version, which is basically all the same ops and kernels, but using Torch. And then I've been refactoring it over the last several days to get rid of Torch, because Torch wasn't doing anything for us, because it was all just custom kernels anyways. But I've like sort of made a mess in the process, and I have to clean it up. So I'm kind of like stupid LLM for very coarse refactoring stuff, and then I'm going to try to like manually get it to something that is actually clean and nice and simpler than the original Torch. It's just a heck of a process, right? Because Torch imposes a very specific design, and it's just completely the wrong design for raw CUDA. So that's what I'm looking at now. Major cleanup on chess. Outdated, took it from 38. Oh, that's a nice refactor. Why 256 threads? You can use way higher here, pretty sure. I go ahead and try it. Like, I think we profiled, but we might not have. We do have a profile script. We have a couple of them. We have like profile kernels, profile torch. It should like break down the time spent in all the kernels. It's just at the summit, you gave a presentation. I want to say it was incredibly enjoyable. Loved hearing about your journey. Thank you very much, and welcome. I messed up and I didn't record the slides correctly for the talk, but I do have the slides and I have the talk recording, so I've sent it over to one of my contributors, and it'll be up on YouTube within a few days, most likely. And aside from that, I just pretty much stream all of my dev working on this stuff. Currently, at the moment, we're trying to figure out how to make less of a mess of the newly ported torch-free backend, where no torch and it still trains super fast, because the design of it is quite complex. It is not that much longer than Torch at the moment, but there is some fancy stuff going on, and it's kind of confusing, so we're trying to just simplify. Yeah. And then these buffers here need to be... Yeah, these buffers are going to have to be void star, aren't they? Low reg pressure and no SMM prefix scan. Histogram check out warp. So the use case, Prashul, it's like this, right? It's min-group. So you do all the map moles nicely batched for your entire sequence. So your sequence is probably going to be something like, 512 rows of 64 each. Like that's a common sequence pattern. And it's the scan op over the 64 dim in time. Now we'd like it to scale nicely for longer, but we can't do it at the price of making it worse for shorter. Ideally, it doesn't need multiple paths where like above a certain length it needs multiple, like multi-stage reduction. I don't know. Are there any obvious bloat packages apart from Torch? Well, without Torch, the core training code is just CUDA. Like that's it. It's CUDA and like CUDA, C. Like there's really no other dependency at all. Now there is the Python wrapper, but that just has like this little pretty dashboard for printing stuff. And then the only other non-trivial thing is the sweeps infrastructure. The sweeps still uses Torch. I believe it's like gPyTorch or whatever. And that's because we need Gaussian process models. So presumably we could port that if we just, like the only reason to port that would just be to get rid of it completely, to like reduce the package install, because like that's only ever used for suggesting hyperparameters. I don't plan on porting that for 4.0. That would just take way, way, way too long. So the training backend will be no Torch, and we'll keep it for hyperrecs. We could eventually do it, but I think that's a lot less valuable at the moment than just like making the core training super fast and super clean and figuring out all the questions remaining here. Split finding. Check out the best split kernels in Warp GBM. Wait, split finding. That's basically split finding. Is it? Wait. So if I recall, I'm pretty sure that the min-row recurrence, you can compute it linearly, or you can compute it in like a log n, in log n reductions. I think those are the two ways you can do it. Is that the same thing or no? Make sure I didn't break it. Okay, I didn't break it. Decoder train buffer. I think these are going to have to be void star, no? Yeah. Ooh, wait, but then the decoder itself can't own the weights if we do it that way. Oh, that's super annoying. We had O of E by K by B, where we needed the best value. This was viable. Back kernels are super simple, but they're 3x faster than LGBM. What is... Okay, I'm not familiar with a lot of the things you're talking about here. Hang on. Light GBM. Wait, what? Light gradient boost. What? No, I'm looking up the wrong thing, right? Warp GBM. Wait, gradient boosting? Wait, how on earth is this in any way relevant? Oh, I see. You worked on this and you had a similar kernel. Okay. I see. I see what you're saying. I mean, realistically, man, the kernels probably are not that complicated for experienced kernel devs. I'm actually quite new to kernel dev as a whole. Like it's mostly I got into this for this update. Um, the idea being that like, okay, definitely Torch is bloated. So if I can, as a complete amateur here, still be making it way, way, way faster than Torch, then definitely longer term that's the way to go because once we get some contributors that actually know what they're doing, it'll get way, way faster. Though I don't know, I think at the moment we do have, I think at least a good 60-70% of the compute is the map moles. So other than like launch settings for those are just kublas. There is still definitely some room for optimization though in the kernels. Like, and still you could get like an extra 10-20%. Would be useful. Do you need the rollout buffers? Encoder, rollout, buffer, word star. I don't think. Gotta go. Thank you. And linked up on GPU mode Discord. Oh, okay. Cool. Thank you. GPyTorch. My guess will be a contributor PR. Probably Jess. I mean, it would be nice for being able to ditch the dependency entirely, but it's not going to do much for speed at all because it's just used for the hypersweep. It's like way, way more important to get the training backend right at the moment. Force inline and restrict. We have that on the actual kernels, man, don't we? We have force inline. What's restrict do? Pointer is the only way to access pointer aliasing. Huh. Weird. So what, this means that there's no, you don't have a separate handle to this? Interesting. I will look into that. Peace. Alright. I mean, this feels so stupid to have this many buffers, no? So it's 4 structs and like, what, 6 functions? I mean, let's just do the best version of this I can first. Oh, YouTube ate it? What? YouTube ate your thing? Self-play for release? Ideally, yeah, like, self-play for release would be great, Jess. Once I figured out how to make this not a mess. Push to 4. Static native branch, Jess. It'll get merged in when it's not crap. Should be soon. Once it's at least as good as the code that was there in 4.0, let's say. I still don't know if this is going to be good. Try that. Four structs and 6 methods for a module. That sucks. We might be able to merge a little of this though. We might be able to merge a little of this. Yeah. Let me think about this in the meantime if you can merge these. So decoder register params. Decoder register train. Why can't you do these at the same time? Because you might not want to register training and register params anyways, right? What about rollout? Can you do it with a register and rollout? No, you can't because you only have to do this one once. So this is actually the minimal set. Store them in a wait struct. It literally, it shifts you to auto accept edits as well, this thing. This one I don't understand. I think this one is the registering param, like the append shapes or whatever. Just add shit for no reason. Oh, jeez. I swear I'm such a dumbass with this. Yeah, this shouldn't exist is the thing. Okay, that deletes that. So this was just LM idiocy. This goes away. We built the allocator specifically so we wouldn't have to do this. So this struct gets deleted, which is great. This redundant function gets deleted. That function gets deleted, and then this this chunk of code here, the shapes chunk, should get deleted as well. See? Yeah, everything gets moved to void star. The param shapes get deleted as well. This was the main thing that I hated, as actually, so. Why are we storing? No, why are we storing this there? And then min_gr is going to get the same treatment, probably. Arguably, we're not even going to need policy. I mean, these get called once, to be fair. Hopefully we don't break this at the same time. I mean, the main thing is we get rid of the weird parameter registrations. And we get everything into, it's got to be void star for the buffers. So you can swap in your own version. Yeah, this is the main thing. I wanted this gone. That's the, that was the goal. So now those functions are all gone. We no longer have any weird weight registration functions. Buffer uses its own RNG seed. Okay, this is fine. These names suck, so we're gonna have to fix those. Signatures suck as well. It's kind of funny how this thing is like actually pretty good at checking uses in a ton of places, but then it's just completely incapable of designing anything. Well, I say this, it's completely screwed it up, right? Ooh. That's easy though, right? We can just get numl from the param vector. Alright, be right back. I'm gonna use the restroom. Hey Ryan, welcome. A little annoying to lose numl on the encoders. We might want to do something about that. Getting simpler at least. Rows. Yes, these buffers need to get distinguished. I wonder if we want to pass. Okay. This matches before. Wait, can you not do... Is this not valid? Can you not one-line these? Oh, wait, you totally... Huh? Can you not do this? Am I stupid? Is there a thing where you can't do that with structs? There isn't, right? So we actually, what we want to do is this goes here, right? What do the decoder functions look like? Decoder backward. Okay, so the registration functions have the same sigs. That would be substantially better, at least. Looks better. Weights, inputs, outputs. And then what's the decoder one? Input, output. That gets merged. So this one, oops. Decoder specific. So we can go up to here. What the heck is this signature? Oh, this just has a massive ass signature, huh? That's just like this. Okay, well, I mean, we'll figure that out. Log standard deviation. Oh, well, this is because the signature is complete crap. Yeah, okay, we just haven't cleaned this up yet. Like, it's not going to look like this. It's actually going to end up becoming the same thing, right? Yeah. It's going to end up becoming the same thing. Cool. We just haven't cleaned it up yet. And actually, if we look at the decoder, what are these things contained in? Policy backward. Speed of buffer comes from vmap plus async env, right? In theory, vmap plus async env. What happens if the model trains in Jack or tinygrad? So in puffer 3, if the training happens, hang on, let me make sure it's right. So in puffer 3, if you spend a bunch of time writing the implementation well, In JAX, you get about the same speed, and you spend a bunch of time compiling the code every run. If you do it in tinygrad, you spend slightly less time compiling the code, but it's a bit slower. And compared to Puffer 4, if you do it that way, then you just lose 5x speed. It's not just VMAP plus async env anymore. It's the full stack. Jax is slow, Torch is slow, everything is freaking slow. And actually, in fact, if you just do the training in Jax with Puffer, you can do it if you really want to use our envs. You're just going to end up with more complicated code. Huh? How did we get PPO buffs puff? Where did this stupid thing come from? Something is weird here. Damn. Train red. Hmm. It's definitely pulling the wrong stuff in, right? Wait, grad logics. W grad log std scratch. Grad input. Shouldn't this live in, this should live somewhere. Yeah, decoder train buffer, right? It's passing it directly instead of passing the train buffer. Constellation sweep. So Jess, when we get to do that, the thing I'm most looking forward to is like finally just pinning down and isolating some of the weird hyperparameter settings that end up coming out of sweeps, figuring out why the heck they happen and patching that stuff. Where's not interested? Hey, where the fuck is the not interested button? Oh. Why do I get this in my feed just because somebody I follow comments on it? That's so annoying, man. Stupid algorithm. Okay, so then this should be... Yes, this is better, right? Deck. The decoder now takes... Let's see the signature. W grad. What about the encoder? Encoder as well, right? Patching things algorithmically? Most likely so, yes, Jess. Unless it is a quirk of the sweep, but it probably is at least some amount algorithmic. Okay, this is way better. So look, now down from having a whole bunch of unique functions. Whoops, that's not let's just keep doing that. So down from having a massive number of unique types of functions, we have one, two. Actually, we're gonna reorder them. Let's make sure it still works. Cool. I think that's not terrible. And then we'll put the struct decoder, the struct encoder, struct decoder. These go up top. So this is the interface, right? The interface will be like this. And if I simply compactify this, because this is not API, so this is actually not needed. The comments, if anything, should go on the implementations. Yeah, the comments go on the implementations, right? Decoder waits. And then these go up here. Go like this. Wait, this is not API. This is, so this actually should get grouped here, because this is not API. Cool. So that's, I mean, no longer terrible. Probably some small renaming and stuff, right? But that's no longer terrible, I'd say. Especially if we just do it like this. This is too long. How do you go about algo work? Guess and check. I mean, it's not like exactly guess and check, right? You know, you have an understanding of the algorithm. You come up with hypotheses on why stuff is happening the way it does. You design experiments to test it, and it's a lot easier when the experiments are fast and comprehensive. Okay, I think this is at least way better than what we started with. This is still a chonky thing to have to do to implement an encoder. Actually, how many lines is this? So we just got it down to 43 lines for the simplest encoder. The decoder is a bit more complex. Not terrible. Not terrible. What is this in total? Like 100 lines? Are sweeps going to take much longer? Of course sweeps take much longer than a single training run. It's linear. You know, you're going to expect that sweeps are going to take like 100 plus times the amount of time. That's why it's important everything is fast. You can parallelize them. Yeah, 100 lines. So 100 lines for our decoder and our encoder. I think it's not terrible. I'm not going to sweep then you're trolling. $100 times 10 seconds equals 20 some odd minutes. So 100 experiments for like short like environments can just be done in like 20 minutes. For complex environments, we'll just run it on like a 6 GPU box overnight and we'll get a full sweep of several hundred experiments. Should I do early stops? Yeah, it's already included for you in the new sweeps. What is this? Assemble decoder grad kernel. This one's a little weird. Oh, I think this is because of the value function, yeah? Maybe that's not bad. Hang on a moment. Alright, cool. Accident with Claude Code. The whole bloody thing is an accident, man. This whole model is just dumb. My justification here is that I'm using it to fix Torch's even dumber code. Like this is not the code as I would have written it, right? This is like incremental refactoring away from Torch. It's not my code until I actually get it into the form that I would want to have written if I weren't constrained with the original Torch. Alex being there is a little weird. I think this is fine. We might just not need a policy, which would be kind of cool. We might want one. And also, like, the implementation of this thing needs to be better. Okay, this is being put back. That was my code from before that I was like, where did it go? Oh, I think we're actually back to the size of the file that this was before I started messing with it. So that means that this whole refactor was free. It's just superior. It's so much work though, man. So much work. Not a huge fan of this. Not a huge fan of this. It's incremental. It is getting better. Network forward function. Okay, so network forward function. This does end up with a different sig, no? Yes. Network forward function like this. So what we do is this goes up because this is going to end up in a header or whatever. Anyways. And then this goes, yeah. Right, like this. Encoder forward function, backward function. Encoder forward function, encoder backward function, network forward, network back. Yeah, this is good. Type def, and then this will go like this. Cut it there. Cut it there. Cut it here. Okay. So imagine you get this as your header file. And then you get your standalone, your network. If this is your example code, and also not just the example code, also your like high-end actually solves frickin' everything network. That seems okay to me. Not a big fan of this being a vector. Oh yeah, let's make sure we didn't break it. Let's make sure we didn't break it. Still good. Mm-hmm. Looks good, right? Lazy model. Good. Oh, actually, these can just be called encoder decoder network, right? Yeah, this will be easier than this. This will actually be very nice. How's this a big update? It's not. This one actually gets to take the types, which is nice. Hungry. I'm gonna get some food in a few, but I'll be super quick. I'll leave stream on even, and just be right back. Yeah, naming of all this stuff sucks. And then this also sucks. I actually am now, the nice thing is, I am seeing how this is going to end up in relatively clean CUDA C. It's going to end up being still a few hundred lines for the whole policy, but like, it's not even that much more than the original Torch code. I guess we do have the kernels that are doing a lot of the heavy lifting, but then again, you're calling a bunch of kernels when you're using Torch, so whatever. Waits, yeah, that's fine. Getting this file today to be nice. I think that as soon as this file is nice, I can probably merge this to 4.0 and say like, we're good. You know, I'm confident that this is the right direction. I can merge this to 4.0. That's pretty much until the policy. While the policy code looks like this, I can't. Because I can't ship this. So I have to basically be certain that this can be refactored into shippable thing. The fuck? Weird policy. Okay, same thing as before. Now what do we have? Got our min grew. Yeah, we've got this. Let's just do Decoder. Decoder rollout. Decoder G. All right, I gotta go grab food. I will be right back, folks. A few minutes. All right, I got some food. Yeah. Who the hell eats peanut butter and jelly, unironically? All right, got some eggs, got some tea. See if this builds or if it's used in policy. If this is the case, we're actually just not going to need all these structs, huh? Yeah, we're going to not need all these structs, which would be kind of cool. And also these deletes are fucking weird as hell. Yeah, these are just like disgusting autos. Dude, what is all of this garbage? Like, ugh. Why is this done with new as well? Like, it's just bad. Freaking language models, man. Trying to C++ify everything. But, I mean, it's still faster. Like, I don't even know why I'm doing this chunk manually. It would literally be faster to do this with the stupid model because of how, like, messed up the code is. Like, I'm seeing more of them here, right? This is encoder train buffer right here. What else would I miss? And before I did the got rid of torch, it was also like 30-second for rebuild. Oh, it's so bad. It's so bad. So work. Hey, it works. Okay, so policy. Oops, actually, let's not compact. Let's just save some tokens. Do like this, it'll be faster. Actually, wait, do I want to do that? I don't think I want to do that, do I? I think that's a bad idea. At least let's not do that right now. Do like this first. Yeah, so you can't be casting shit to encoder weights, decoder weights like that, right? Yeah, you can't be doing this. Saved input, yep. This is the problem. So that's probably a bunch of it right there. My stream title is still wrong, by the way. It just didn't update correctly. Oh, does the decoder get simpler? Wait, decoder, backward function. It takes waits, train buffer, value, grad input. Interesting. Okay. Bad language model. Stupid. Why did you even want to do this in the first place? How comes the model struggles to learn and other times it learns very fast? Struggles to learn and other times. So local minima don't exist in weight space in the way that you're thinking of. In policy space, they do because these or strategy space rather, because strategy space is low dimensional. So like, yes, they can just like not figure out what is the next thing to do to advance in sparse environments. Yeah, this is why I actually have to be like looking at this because it does. Like, see, it just started trying to add stuff to the API that's completely redundant for no reason at all. Ask the model to explore more. You can't. Like, well, what's your environment? Like, how fancy is it? Because it's a very different answer, right? If you're asking like, how do I solve Flappy Bird versus how do I solve, I don't know, Neural MMO3. Lights out game. What is that? Oh wait, isn't this the frickin' clue scroll thing in RuneScape? No, it's not. Wait, are you doing it on 5x5 grids? What's the reward? 5x5 got solved fast? Yeah, expected. What's the reward? Step penalty. And final reward. Huh? Well, I think you just have terrible rewards then. What's the game tell you? Switch all the lights off. Number of life dits. Yeah. Why don't you literally just give it a reward of plus 0.2 for every light that it turns off, and minus 0.2 for every light that it turns on? Oh shit, I see the problem. Yeah, I see the problem. Oh, that's so annoying. Think of how we handle this. It needs to open more lights in intermediate steps. That's fine. You're randomizing the puzzle start, right? It also has a time. It should have a timeout. Like if it fails the puzzle after a certain number of steps, you should just reset the env and give it a -1. Or just, yeah. Ah, shit. Man, just when I thought we had it. But how are we doing this at the moment? How are we doing this right now? Oh, we're cheating with the cast, aren't we? Oh, are we? Wait, are we cheating with the casts? Decoder forward. Encoder forward. Map mall. Yeah, we're cheating. Yeah, we're cheating with the forward. That's so bad. Ah. That's like so freaking bad. I hate that. Well, Now we gotta think about that thing. Lovely. Well, you can't freaking do this either because the shapes, no? This does kill a struct, doesn't it? I think this could work. Save this one struct. Tiny, tiny amount of wasted CPU memory. CPU memory that should not matter. Funny puzzle. Very funny puzzle. Oops. Heh. It's actually kind of hard, isn't it? And then you have one freaking thing, yeah? Hmm. Alright, cool. I hate puzzles. I have RL agents to solve puzzles. I am absolutely terrible at all puzzles. Thinking hard, me lift big rock. If we just end up with a wait struct and an activation struct, that is super clean. Oh, technically, there's one other way we could do it. We'll start with this. Now, this should not be casting. Where's the casts? Okay, good. This is no longer casting in here. We have a much shorter policy function. Good. Okay, let's just go through this. You can actually see what the hell is going on here. Presumably this is bloated. We can't freaking see it though until we clean it up a little bit. Just like one-lined a bunch of crap. There. Yeah, it's just one-lined way too much crap. Including this. Let's start with this up here though. Let's see what's going on with MinGrew. I don't know if we're going to want to keep it like this. The other option is that we could end up with like two separate buffers to like depending. Installing DaVinci on Ubuntu. Hey Weston, how's it going, man? Sweltering. You get you some better hardware, man. Like, for doing all this research and stuff. So close. Oh, happy to help with that then. I gotta go, like, I guess I could put some bounties up on Puffer. The thing is, I've gotta get, it's always, like, so in flux with 4.0. Maybe once it's stable, we'll assign, like, a dollar amount to specific things. Okay, this is exact same as before. We are happy. Yeah, we are happy. $600 because of the freaking RAM. Jesus. Is it still cheaper to build them, man? Like, some of the pre-builts get better deals on that stuff and don't get scalped on RAM. Especially when you're getting discounts. Okay, let's see what this is. They can raise the prices on pre-builts. Yeah, they don't always, though, in the same time. Like 10 years ago, it used to be the case that you always would build your own thing because the margins were just nuts. Nowadays, it actually kind of depends. It is probably still generally cheaper if you really want to hunt around. Um, I don't do that anymore, of course. But... Why the hell's this gotta be vector, huh? Looking forward to seeing the slides as well. Yeah, our Weston's editing it for me. 5090 alone at 3 to 4K. Yeah, freaking ridiculous, man. I'm gonna go check out the pre-builts pretty soon and see if we can order some, but if they're gonna be that priced, like, no thanks. They mostly are, Lav. Is this still here for 5K? It's not, right? Sold out, yeah. I mean, if I can get them for 5 to 6K, I'd be happy with that. If I'm not paying 7K a desktop, they're upping the prices of 5090s to 5K. Fuck that, man. What makes a good environment? You see 2048 and breakouts, obviously the canonical example. So Arch Breakout has been historically for us the simplest, fastest environment that is still broadly indicative of performance. So if you use Pong, Pong is too simple. Anything solves Pong. So something, oh, this solves Pong fast, that means nothing. Breakout, typically, if your thing works there, there's a decent chance it works everywhere. If it works on 2048, it's almost guaranteed that it works everywhere. And if it works on Neural MMO3, then it definitely works everywhere. It's not you know it when you see it. So like 2048 had it was a very well scalable task, right? Where you could pour a lot more compute in than you'd expect and you kept getting better results. It just like was a very, very hard scaling task. Those tend to be likewise better transferable. When you have an env that you just insta-solve in 10 seconds, sometimes it transfers, sometimes it doesn't. We have some that we trust more than others because we've used them before and the results have or have not transferred. Jesus. What was the original MSRP on these? Freaking Scam Altman just sitting on all the RAM. Or whatever. D70 Ti. That Omen's still a great buy. I literally, so what I did relatively recently. I literally just did this. Click, click. Where is it? There. I think this has actually gone up a couple $100. But I think I got something around this. Oh, where's the quick ships? Well, they have laptops as well now. Might end up getting one of those eventually, we'll see. My laptop sucks at the moment. I'm sick of buying the Razer ones. They keep screwing stuff up on their QA. Pokemon Showdown being built. Difficulty with using a potential benchmark. Complexity correctness of the end. Yeah, pretty much. Just have to get like the thing implemented, fully tested, fast. It's a big engineering project, right? I think we either split this to be min grew layer, or we just have it joint. Let's, I guess, look at the logic for that. If done properly, do you think it would make a good benchmark? Of course. It's a little tough because you need self-play to really get good results, and self-play is still hard. Otherwise, you need to have like a good scripted baseline. If people made like decent, fast heuristic scripted baselines, it would be really freaking good. Even without that, it would still be like pretty darn useful. The only thing I gotta make sure is I don't get sued by Nintendo over the assets, so we gotta be careful about what we like, where we do that, or how those get hosted or pulled from. I don't know if we just hook it up to an existing front end and just have the sim code or whatever. Nintendo don't, yeah, exactly. I remember I went to GDC to like talk to game devs about different game companies about RL, and pretty much everyone there was chill and would talk to me except Nintendo. You know, you had like Epic there, you had Riot there, you had like all these awesome companies, and then like for whatever reason, Nintendo's there just like thinking they're the shit, and they're like, oh no, we have no one to talk to, it's a technical whatever or whatever the fuck. It's like we have interviews only. It's like okay, yeah, okay. You don't bring business development people to the conference. Cool. Puff copy. Hang on, this is X state I dot bytes. Ooh. Hmm. Wait, that's so weird, isn't it? Plus 1.2. Hmm. That's actually a very heavy markup. I think that a lot of these pre-built companies, they've sort of like taken advantage of the volatility, Or maybe they're just increasing their margins because they want to hedge against the volatility. Either way, you can blame that directly on Altman. Because how protective of their IP. Yeah, Nintendo's just like lawsuit happy for whatever reason. It's kind of funny, like there are a few of the bigger companies that are actually really chill and they like when people do cool stuff around their games. And Nintendo's just like, you drew Pikachu, get sued. They had this whole thing where they were like trying to ban Twitch streamers from playing emulated versions of their games. They're just like, oh no, you have to stream it on a freaking original Game Boy. It's just like, are you shitting me? But nope. They also like don't want people doing ROM hacks as well. They think like doing ROM hacks is like the same as stealing the game or whatever. I don't even know. They're nuts. I don't know what the hell's wrong with their legal as well, because like, I mean, Nintendo's been such an awesome company for the stuff they've produced over so many years. Their legal is just nuts. I have no idea why. It's like super out of touch. Because it included a Smash Bros. Game. Dude, you can't just like, yeah, you can't play our games in public. Like, what? No. I mean, the fans, yeah. The biggest thing that they ever got me on, this is ridiculous. Yeah, this is the most ridiculous thing they ever got me on. And the reason for this was my favorite. This was my favorite growing up, and I was like always sad that they never made a big one. And then in my mid 20s, they made a big one. So damn it, I'm buying it. So now I just have one of those. In 2013. What was this combined 3D? Why are we editing the shape? Like, what? Oh, is it just because we don't have a batch map mall? Ugh, I see. It's just like, no. Alright. I watched the Opus stream. The original one was so dumb and brain dead, dude. I'm not doing anything remotely like that. Did you do the pufferfish animations? No, I hired a couple actually different artists, and I'm actually going to be hiring I'm going to be hiring more artists for the pufferfish quite soon. What the heck? Batch times equals MM split. The heck? No, I hate that. Buffer is getting. It's gonna look very similar, just streamlined and better for doing more animations. 24 is 5% more expensive. That's funny. Maybe better. PR for lights out? Awesome. I will get to that. Keep reminding me if I don't, because I've been kind of grinding this thing. What do we got here? Looks reasonable. It's a really shitty CPU cooler, isn't it? A 9950X with this cooler? Really? I do actually recommend air coolers these days now because I'm sick of dealing with the all-in-ones, but not super cheap air coolers. Okay. So this now no longer looks awful, right? Oh, that cleans up this. Not getting. Scan buffs. Scan buffs. equals. I see, so this buffer's kind of weird. RL checklist, reinforcement. It's in there, as well as I think there's also one on the website. The quick start guide just like walks you through everything and links you to everything. Oh wait, the quick start guide or the yeah, that one I think has most of it. Does it? It might just be on the website. I don't remember. I mean, literally just doing this will catch most of it. Just literally doing this will get most of your stuff on the website. Can somebody explain to me what's going on with this live? Hi, I'm Joseph. I'm an RL researcher. I stream all of my research. I build very, very high performance training, inference, custom architectures, custom simulation, and I stream all of my dev. We've got demos at puffer.ai. I am currently refactoring our new backend, which trains at 10 million plus steps per second without even needing Torch, just in raw CUDA. And I'm going to try to make this thing simpler and easier to use than even Torch. That is the stream at the moment. I've got it decently simple, but there's still quite a little bit of bloat around with this. I don't like the way that we're handling min-grew activation buffers. I don't like this loop. I don't like all this indexing. I don't like these assigns. FuseScan not taking the prefix buffers jank. Yeah, okay. We'll do that next. Let me grab a quick refill on my tea. I'll be back in a couple minutes. And then what we're going to do is we're going to see if we can unjankify the min-grew layers. And once we get this thing down to something more manageable, policy will be very easy from there to fix up. And then it'll end up being like 300 lines worth of stuff outside the kernels total for the whole network, which will be great. I'll be right back. Okay. I'm back. So let's take a look at this. Prefix scan. This has a star vowels, right? So isn't this supposed to just take the prefix scan? It really should, shouldn't it? That's the whole point of it. Not done with its bullshit. K38. You did it? What? You got it exported or what? 32-bit time. Uh, yeah, that's way better, right? So it's on Linux. Oh man, that's Linux editing for you. Oop. Yay. Name and kernels is and Encoder and forward and forward and Download the VOD. I did. I sent you the drive link, man, didn't I? And get it 1080p, right? And we should be able to get 1080 out of it. VOD isn't there. You sent the M4A. Let me double check. Shit. Why did it not upload, dude? You're right. I don't know why. Hang on. There, I have it. It's set to upload. Let me know in 2 minutes if it's not there. Cool. Okay, cool. I gotta reply to this guy in a bit, but you got a cool course project. Please reply. Can you wait? Hang on. Can you please tell us what's the purpose of your RL or research? Uh, Please reply. Yeah. So I build very high performance reinforcement learning tools. My work is really a like overarching and general attempt to fix the things that I think are wrong with the field. Um, as of when I started it, it was mainly experiments being so slow that people were running improper and insufficient experiments, and the results were mostly invalid. The vast majority of papers did not actually transfer to other similar complexity problems. They were incredibly tuned and overfitted. There's a complete lack of complex and interesting environments for training and evaluation. People weren't actually then taking these tools and trying them on real problems in the real world. The literature itself basically made it impossible to make a real progress on the algorithms because for anything that you would try, there would be a ton of algorithms out there that claim to solve the problem that don't work in practice and that use benchmarks that are too slow for you to evaluate on yourself. So it was a ton of different things. And the goal of Puffer is to just be a ludicrously fast and simple platform for doing all sorts of RL research. We do our own environments now so that there are fast environments from very simple to very complex for evaluation. We do our own algorithms research around them as well. We pull in some things from the literature, but me being graduated, I'm no longer constrained to be evaluating against papers that I know actually don't work in practice, and like trying to run evals on slow environments where it's virtually impossible to do so. So it's really an overarching effort. We have a ton of people now that have gotten involved with this through the open source. We have this working on some real problems as well, and the methods are improving too. What I'm doing at the moment is I'm really trying to understand what is the actual hardware limitation, like what is the actual cap speed that we can get, where are we wasting all of our compute in RL, what is the realistic limit of how far we can push performance. And to do that, we're doing our own low-level backend. This is really nice for letting us play with different architectures at the actual speed that they are capable of running. This lets us cross-evaluate different things much better. And honestly, this is in many ways like there are things that are difficult to work with here, but there are more reasonable things than the difficulties I've had working with Torch before, and we're already getting a lot of mileage out of this. So the next update to Puffer 4 is mainly going to be this super fast raw CUDA backend, as well as some tools for large scale experimental analysis and a bunch of new things with that. That's kind of the gist of what we're doing at the moment. Let's see if the, let me see if the, and why is the, do I keep like closing it before it updates or something, or before it uploads? Here, listen, let me try one last time. Something's screwy with it. Can we do customized algorithms? Yeah, of course. Why not? And how do you think I changed the algorithm? What Puffer isn't going to do, though, right, is we're not going to be a library of every algorithm out there that doesn't actually even work. That's the problem is most libraries, they focus on just trying to implement every algorithm. The algorithms don't even work, and they're super slow. So what's the point? Okay. Way better, right? Wait, how is this grad equals that is sketchy. Yeah, that is sketchy, I think. This is way better though. This is probably better memory layout the way we have it. Yeah, it's probably better this way. So then it's just a matter of like, why does it still look kind of janky? It's so weird, isn't it? Yeah, these resizes are annoying. But then the prefix scan buffers kind of make sense the way they are now. Yeah. Static cast. I don't like this. Nope. Hang on. I'm trying to figure out what I don't like about this. I guess let's see, state of I. Mini brew state layer. Hmm. Yeah, this feels super redundant, no? Of copy. Not the best, but better. And then the scan buffs is like weird, right? BT hidden. And the scan buffer should just be the same size. Something like this, right? BTH at the minimum. Right. It's better. Need that anyways. Can see the file? Good. Okay, that's looking at least somewhat better, right? Not absolutely horrifying. View scan forward. Why are we overwriting grad? Yeah, why are we overwriting grad and returning grad? Wait, grad, wgrad activations. It is the same, isn't it? A grad input buff. Let's try this. I don't know if that's the same. float instance here. It's been demoted to be slightly smaller. Ah, so this breaks it. Hang on. Grad equals. Oops. Alright, how is that not the same thing? Am I being dumb here? Or is this not the same thing? It's weird. Transfer fully scrambled 8x8. There you go. Was that did the new rewards help, or did you do something else? Scan backward. Scan. Right, it's there. Right? And we do it like this. Scan. Scan. There. Diff number after a click. Is that what you did though? Like for the reward? It'll be a nice env. That's kind of cool because that's already tough for me to do. Like I can't freaking do that easily at all. I mean, there's an algorithm I could learn, I'm sure, but that's very nice. That'll be a cool little demo env. Now the real question is, did you make the lights puffers? We could? Yes, you could. Yeah, that's how you get me more excited about merging the env in quicker. That's a heck of a lot cleaner. Because otherwise... Yeah, otherwise you gotta resize the tensor every time, so I think this is fine. On graphs next. Lights out on graphs. What? Ay, look at this. What on earth? What the heck? I see, this is the flatten, huh? Yeah, this is the flatten. That's not that bad though, right? Right. Okay, that's actually a pretty simple forward function, isn't it? Nah, you don't have to do that. Having the normal game is fine. You'll make it too darn complicated for anybody. Like, the thing about making really hard ends that people can't understand is they don't appreciate that they're actually interesting. It'll be a nice end. I hate this initializer list. And it's annoying. That's super annoying. Decay to pointers and lose this size. Yeah. Doesn't allow. Wait, C++ doesn't allow assignment to arrays. Is this a C thing or a C++? That's so annoying. To its own struct. That's really annoying. So basically, it's like just keep it how it is now. Yeah, I don't know what is great. I don't know. Hey, what's up? I wish there were a cleaner way to do this, you know? You'd need to be able to reassign dot shape. Does your work on Puffer 4 provide any insights into ML beyond meta is silly and LM browser silly? Curious if low levels provided you with any unique insights. Well, I mean, Jazz, like the insight is we're kind of going to be able to steamroll much harder problems with very, very little hardware. Additionally, this brings the architecture design closer to the hardware. So we actually get to think about like what ops are computationally efficient, and we get to test that much more cleanly. I honestly think that there's a huge mistake at the moment in that you mostly have a lot of researchers who don't know how a GPU works writing ops that are horribly slow, that are like better in better in samples or whatever, and they're just crap. So it's like very uncontrolled experiments. Oh, yeah, that is a lot simpler, isn't it? Okay, you probably want to squeeze up. Steamrolled light mode. Imagine that with Puffer 4. Yeah, that's what we wanted, right? Yeah. Okay. Policy is way cleaner. Went into the call args. Yeah, this is better. We're about the same amount of code as well as when we started. Networks. I see. It's actually that view op. know what this NS Life even is. Is this the next thing to refactor? It is, right? So let's look at our code. Let's see what's still a mess. Tensor's gotten a little chunky. Default values on some structs. Allocator sucks. This isn't bad. Isn't bad. Map moles. Orthogonal is a mess, but we don't even know we need it. We've got a couple additional matrix ops, a couple tensor ops that we don't know if we need or not. They're like not too bad. There's your main PPO loss. So we do have a bunch of stuff up here. But then from here, it's only 220, is it 300 lines? It's not bad. That's not bad. Yeah, okay, that's not bad. So I guess then the next question is, do we try to get different encoders working? %50 of knowledge-based work could become obsolete in 3 to 5 years. Yeah, so I have a very low opinion of Anthropic in general. I know that's despite using Claude at the moment. It's not so on their technicals. It's more so that they're just incredibly out of touch. And like the thing is, okay, which 50%? Like the 50% that's basically useless already? Exactly. So like when you say 50%, it's like people say, "Wow, 50% of knowledge-based work." It's like okay, well if you're gonna say, in my view, like 50% of the work is already useless, right? So if you're just looking for an excuse to fire the people who are basically useless anyways, then maybe this gives you an excuse or whatever. Maybe, but like that's not what they mean. I don't know. I don't like Anthropic in general. They're very, very out of touch. Like Anthropic was actually just the nuttiest and most out of touch people leaving OpenAI to go form their own thing. I remember some conversations with some of the people that like joined very early and they were just batshit. So I don't think I'm gonna take any of their grandstanding like seriously one bit. Dario's batshit? Abso-fucking-lutely. Absolutely. I will say though that having read his latest essay, I I don't think he's intentionally doing this. I think that he thinks he's doing the right thing. Cute. Yeah, I think he's just like psyoped himself on that one. I don't know. My general read at the moment, and who the hell knows, I could be wrong, but I think Demis is a genius and is not grandstanding about frickin' everything, and is mostly like still doing a ton of other things with AI. It's not just throw the LLM at it and hope it solves everything. Um, I think Dario thinks he's doing the right thing, but is nuts, and Altman is just knowingly lying. Does that cover everybody I could possibly piss off? I think just about. Any guess on Willie is up to? Not too much, Jess, but from his interview, it seems like he is thinking about things that are very far out there, not just like a little bit different from what people are doing at the moment. And if that's the case, I hope so, because we need more of that. Proof of that's right in here in front of you. Like, I should not be able to just, yeah, let's make RL 10,000x faster. Like, you're not supposed to be able to make 10,000x improvements. Only happens when people are just hard trolling. I mean, it's kind of cool in some sense because, like, if I couldn't be making these major advancements, then I wouldn't be motivated to work as hard as I do, and I'd probably just do something else. But it's still, like, ridiculous. Elon. Um, I mean, I think he is actually, for the most part, being honest with everything. I think he's just newer to. He's like doing too much stuff and he's messing up some of the technicals on the decisions. I mean, I'd way rather see him in charge than Altman or whatchamacall, Altman or Dario. I also think that their eng focus is something that I really wish DeepMind had. Um, that's like the fatal flaw of DeepMind is they do too much math when the answer is engineering. Like they've only got one tool in their toolkit. It's bash the thing with math until it falls over. Still quite a bit of stuff to clean up here, isn't there? See, I want to clean up Muon, but I don't know how much we can until we fix the rest of the stuff. Max engineering. So I definitely like am very low on the math side, but I do think that if I saw something where it's very clearly like, look, this is a math problem, not an engineering problem, I would take the time to go after it. State space models actually were kind of like this, where I guess this is like really simple for math people, but for me, the prefix scan stuff is really unintuitive and non-obvious. So going in on an architecture like this, that it was really confusing to me, like that's one example of, okay, maybe we need some math. Muon is another example. Muon was awesome. It just doesn't happen as often as is the case that you just needed to build the stuff to not be crap. I'm just suggesting to open source contributing for large programs. If we just start. I mean, I have an RL guide out there, right? This is literally how people get started with my stuff at the very least. I've made it pretty easy. You don't start by doing this crap that you see me doing here for sure, because I barely know what I'm doing with this. That's why it's like open-ended. This guide will walk you through much more gently in a way that will get you building stuff pretty much immediately and fill in gaps with what I think are the most useful papers along the way. That's what I would suggest. All right, let's see. The only thing that I don't know what the damn allocator is. Wait a second. Wait. We don't need the vector, do we? Puff tensor shape. Puff tensor star pointer shape. Oh, wait. We got it, right? It's kind of jank. Referenced that before. It's really all my best advice in one place. That and the programming and ML guide, if you're newer overall. And a master's thesis in RL, any advice? Maybe NYU, Eugene's lab. We work with them on driving, like autonomous driving. They do a lot of sim heavy RL work. Other than that, if you're in the UK, Jacob Forrester's lab. I don't know if they do masters. They probably do. They probably do, right? I don't know how it works in the UK. Transportation, there's Kathy Wu's lab. Polkitz at MIT does a little bit of RL sometimes. Robotics, there's Berkeley, all those labs. There's a little bit at CMU as well. What's his name? Russ. Russ, I think, still does some RL. Those are the ones that come to mind. Oh, yeah, there is some at Stanford, but not too much. Chelsea Finn? Is it Chelsea Finn? Yeah. Some. Though I haven't really seen her work. I don't know about... I haven't actually seen much of her work, so I don't know if I say that yet. Allocator's gray. I think there is a way to do this. I'm not fully seeing it. But I think there's a way to do this. Okay, so this is, we get rid of this reg. Initializer list on shape. Not happy with this either, right? No. What would the ideal be here? Problem is it has to get assigned to what prio buffers? Register prio buffers. It's kind of weird. I'd think about it for a second. Let me use the restroom. I'll be back in a second. All right, I figured it out. I think I got a good solution. Do you ever run hyperparameter sweeps, by the way, or is that silly tinkering? You did not just ask me that, dude. All right, I gotta show this. This is ridiculous. How on earth can we not possibly... You see this? You see this article? I spent months coming up with the best hyperparameter sweep algorithm out there, building the best hyperparameter sweep infrastructure in RL, and making ridiculously comprehensive results, running tens of thousands of experiments. We always run hyperparameter sweeps. If you're not running hyperparameter sweeps, you are trolling. You're not doing real research. Exception being if Puffer is so good it just solves it out of the box and you go, okay, problem's done. All right, so here's the cool fix that we've got to make this registration stuff not suck. Running one right now, it feels like I'm overfitting on the solve problem. So I was thinking I was doing something wrong. I'll read the article though. Yeah, so the point of hypersweeps is to know that you're not failing because your hypers suck. In RL, you are very often failing because your hypers suck. Now, let it be known, right, that as Puffer has gotten better, we've gotten more stable so that our defaults have been generally good for a wide range of problems. But hypers are still like top. It's either hypers or sim bug. Those are the two biggest errors. If your sim is correct, then it's not learning, it's probably your hypers. And sim includes having like some sort of at least remotely sane reward structure. You have YouTube vids on some of the slides. Would you like me to download them and insert them instead of having them on a slide? Yeah, that would work, Weston. You can like request access to anything that you don't have. I mean, if you like whatever, as long as they move and like you have the video in some capacity at a reasonable resolution. You don't have to go too crazy. Just do something that's like relatively quick for you, you know? We were told today that puffer's default. Wait, when did I say that? We were told today that puffer's default params were good for 99% of use cases. Yeah, that's not true. On simple problems that look similar, maybe, but like, so the like puffer being good like almost all the time, it includes you running a sweep. But like the point is the sweeps are super fast, right? Drone. Oh, well, I mean the thing is that in their case, like you gotta realize that they are doing variations of a drone problem. So once they have their default hypers for a drone, like most of the changes they make to their env, like they won't have to retune the hypers. Does that make sense? So like around in a specific problem, once you have decent hypers, like you have to make quite a substantial change to it before your hypers are completely invalidated. But if you try to take the drone params and use them on like checkers or something, that's a very different problem. It could end up being very different, but it's automated for you, right? Sweeps are part of our standard tooling. Let me see your example. Uh, You can just, you know what you can do, Weston? You can put it the full size. You can put my stream the full size and just like overlay my cam on top of it. That'll be better. You can like flip it if any of the slides are horribly, horribly obstructed. And then you can make my cam a little bit bigger if you have the resolution. So just like keep the video the full size, my cam like here, basically this, right? And order, where is it? Send to back, bottom, and then like this. Like this. Something like this, yeah? Good? If that's easy enough to do. adds a little bit of code. And Encoder init waits. Okay, and update the. Let's skip around. I gotta go to dinner fairly soon as well. I just want to get this pattern in. The one thing I don't like is you dupe the lines. I like the single line register like this. It's very nice. Like this is pretty nice here, right? This is just a struct in it. But then I don't like that you have to have this down here. And I don't have a good way to do that. So this will add lines, but it's in the good service of this. Maybe I should line up the shapes, you never know. I don't usually do that, but maybe this is the time to do it. It's definitely adding lines. But what then the nice thing about this, it's the allocator that gets better, right? Yeah, the allocator is way better like this. Way better. This is like actually a not total crap piece of code. Can you please explain in layman terms what you are doing that will cause that much of improvement? So the title, oh, that's probably why we have all the viewers. The title is from the talk that I gave a while ago. The stream title didn't update. So we already have made RL 10,000 times faster. Like, yeah, that's what pufferlib does. We rewrote the entire stack of reinforcement learning over the last 2+ years, and everything from multiprocessing to the environments to now the entirety of training down to replacing Torch completely in custom kernels. Like, everything has been rewritten for perf. So it's not just one thing. Now, if you want to get from like the speed that people were at to like 10x faster, all you needed to do was fix the really bad multiprocessing backends and increase some batch sizes. If you wanted to get to like 1,000 times faster, you needed to do that and also move the environments into memory optimized C. And then from there, that's when you had to start actually looking at architecture modifications and replacing some of the slow stuff that Torch does. You can check out the demos on puffer.ai if you haven't seen them. do feed the puffer star on GitHub. Helps me out a ton, and it's free. Yeah, we can train these environments at well over 10 million steps per second now, most of them. Asked when to apply RL, and I wrote down it was good at solving fiddly optimization problems. You expanding on this since I didn't write down. It's like fiddly, unintuitive optimization problems. Control is a great example of this, right? Control is a fiddly, unintuitive optimization problem. Mechanics in games, like if you think of mechanical control in games, it is a fiddly, unintuitive optimization problem. A lot of industrial sims where it's really hard to write scripted policies, fiddly, unintuitive optimization problems, right? Like anything where it's like, well, I can't really describe this problem well in natural language. It's not really super visual. It's just like a bunch of states that got to get mapped to actions, and we don't really have a good way of doing it. I don't know. We could come up with some heuristics, but that's really tough. Maybe we can do search. Maybe it's really hard to do search because it's too big of a space. Reinforcement learning. And the only caveat is it also has to be fast to simulate. But oftentimes, even if it isn't fast to simulate, you can make it fast to simulate, and people just haven't bothered making the sim fast. For instance, if you want to write a really good simulator for depression, all you have to do is write all your code through this piece of crap all day. I'm looking very much forward to not reinforcement learning myself with this crap and getting back to writing my code manually. But alas, the torch code was so bad that there's so many refactor ops before it gets back into that shape. It's going to be a little bit. Let's see if this broke all my code horribly in the process of doing that. Oh, lovely. Yo. Good job. ML M? Is that MILP? I've never seen that acronym. MILPRL. Oh, mixed integer linear. Yep, okay. So if you want to do a whole bunch of fancy math, yeah, a lot of things can be framed as convex opt. If you can do it and you're smart, then go ahead. If you can't do it, or if you're not smart enough to do that, then you can do some RL. And you'd better, the other thing is, it better actually be a mixed integer problem. It better not be something that you're modeling as one, where that's the suboptimal solution, right? Because if you're just modeling something as that, right, then RL will do better. How are they different from regular deep learning? Well, a lot of things. You have a simulator in the loop, so supervised learning by comparison is so easy to write infrastructure for. You don't have to run simulations in the loop, right? That's like the major source of stuff being hard. The second major source of stuff being hard is that the networks are small. There are two things that are hard in a deep learning infra, right? It's optimizing stuff for small networks and optimizing stuff for large networks. Medium-sized networks are really easy. So those are the two biggest ones. Also, if you're talking about like supervised learning as in language modeling, for instance, they're basically solving one big problem. So they don't have stuff like horrific hyperparameter jank that they have to retune constantly per problem. A lot of things that we have to deal with, they just don't exist over there. I don't know. I started off in NLP. If you want to see my first paper, which not exactly amazing work, there. It's actually language modeling. I think I have the code. The code wasn't even that bad. There you go. I wouldn't exactly use it as a reference. Wrote that one's like 19, maybe younger. Please don't have broken. Oh, you broke all of my code. Sad. Let me see in the meantime if this even makes sense, though. I think this syntax is kind of fine. This sucks, doesn't it, that you have to do these separately? I could do dot register. I could also do register over an entire buffer at once, so it would be horribly janky to do it that way. Anybody have thoughts? So the thing is, you need to specify the size of your tensor, and you also need to be able to register the tensor, because the allocator needs to know the size of it, because we're doing all of our allocations in static memory. I guess we could technically, we could make the allocator eager and then like reallocate or whatever, or have a max size. We could sort of rethink the allocator. I don't think that was the bug. Might have been. And I didn't think that was the bug. I could have forgotten to rebuild. Oh, that was the bug. Cool. Numerically identical. Good. Um. Uh. Well, let's look at the allocator itself, because at least this is better now. This is at least better, right? I mean, all that this is doing is storing all the tensors, and then when you call create, it's just mallocing everything, right? And it's just assigning the bytes. The only thing I don't like is that being a vector, but like, you know, whatever, right? Other than just using a vector, I don't have any complaints about the allocator, really. This I don't like. I don't like that you have to separately create and register. Let's see if it comes up with anything. I can't really think of much here other than, I mean, we could do like a dot register on the tensor. I guess. That'll make the lines annoyingly long. Anybody see anything better than this? Bleh. Ooh, yeah, that's a really jank. That's the thing that I was saying before, that I could do it once for this struct, but it would be really sketch. If I do that, I know a user is going to hit it and they're going to spend 3 days on it. So, like, I'm not doing that. I already have one place in the code where that's basically unavoidable, and I don't like doing it that way. That's super brittle. I mean, basically the only thing that the thing that I'm fighting here, there'd be several ways to do it if I could just pass, if I could just use this syntax anywhere other than in a struct, I'd be fine, right? Don't fight C. What's the C way to do this? That is so, like, this is really clean right here. I mean, arguably, I don't know if I want to do like this, right? And like line them all up or whatever. Like you could. I don't know if I want to or not. But like, either way, this is super, super clean. And then the format's like a matter of, I mean, we'll figure it out. But just being able to do your whole struct like this and like, hey, here are your tensors. I'm not seeing many alternatives and I gotta go to dinner soon. Anybody seeing anything? If I'm not calling this in the function, does it do anything else? Gonna head out. Thank you. Thanks for stopping by. Hope you enjoyed. Star the puffer. Helps out a lot. Wonder if did anybody go star the puffer after the talk? Did we get some puffer stars? 50, 65. Some stars. Beat the puffer. That's so annoying, isn't it? I mean, come on, there's got to be a better way to do this, no? So, the shape initializations are very, very nice. And arguably we could do... I could do the brittle thing. That's so bad though, isn't it? Bus stop equals... I don't think that you can do that. So the one-line version before was initializer list based. So I'm thinking like, oh, that looked nice, but no, that was the gross initializer list thing. Well, at least we know now that like, if I want to go that way, I can. This is the C way to do it here, isn't it? Is you just write slightly more C code. But you write very simple C code. Okay, well, failure on line count from that. Win on simplicity, failure on line count. The problem is you can freaking, like, you can forget to register. No, but if you forget to register the thing, it'll just, like, hard crash on it, and it's a very easy to fix error. That's the thing. Some of these SIGs need to get updated a little bit. Like, I don't want to do star A equals. I'd rather just make it here, right? Yeah. Okay, so if we're going to say that this is reasonable, at least. It's so much freaking code. It's so much freaking code. You can do it so easily with the stupid initializer list is the thing as well. But well, it adds a layer of indirection, so I actually don't even think that's good. Yeah, actually, it's not even good to do it that way, is it? Can you give me edit perm so I can see properties of image? Yes. Do not break my presentation, please. In case I need to give this again. I will give you a link. Link. Gotcha. Cool. I'm gonna go get dinner, folks. Thank you for tuning in today. I might stream some more later, but I kind of need some rest. I've been doing this a lot lately. I mean, I'd say this was decent progress, though. Like, we didn't really shorten the code, but it's a hell of a lot simpler. This is approaching something that I think is reasonably shippable. I'm not super happy with the registration stuff quite yet. Obviously, like, Muon's a mess still. I think a couple, like, I think the loss function is still a mess. But this is getting to something decent. I do really want to figure out how we can just make it shorter, though. I'm going to think about this over dinner, like this registration stuff. I'm going to think about if there's a good way to do this. I'd really, really like to not have the C++ crap in here. So, I'll think about it. For folks who tuned in, thank you very much for your interest. If you want to support my work for absolutely free, feed the puff or a star on GitHub. It really does help out. You can join us on Discord if you want to get involved with development. You can follow me on X for more reinforcement learning content.